Hi, it's Bob here, and I'd like to showcase a chat project I made recently. This project uses the Mern stack. The local and online databases will use MongoDB and MongoDB Atlas. I used Mongoose to access these in JavaScript. The server will use Express.js, and it will also host a WebSocket server as well as the endpoints. The front end will be made in React, and I'll also use Node.js. So here is the login page. The username and password inputs are validated. This means the user will get a warning if any entry is invalid. There will also be an error if the credentials are incorrect, as the API will return a 400 type status code. I'll go ahead and use the demo account. So here we have some contacts and conversations that have already been added to this account by the seed function. If I click on a contact, the message history is fetched from the Mongo database. I can load the app up again in a new tab and go straight to the chat page. This is because the user is authenticated with a cookie token until they choose to end their session. I'll do that now and log back out. So now I've got two browsers open, Chrome on the left and Firefox on the right. I'll register a new account on the second browser and add the original account as a contact. When I log into the first account, you can see that the WebSocket server is notifying the front-end clients as to who is online. I can send messages between the two accounts in real time via the WebSocket server. If I log out and back in again, the message history is retrieved from the Mongo database. I also incorporated loading wheels, which we can see if I simulate a slow network speed in the browser. On the login page, there is an indicator showing that the client is waiting for a response from the server. Various buttons tied to API calls, as well as the main chat screen, all show loading feedback. Sending a message uses local optimistic data, so it is a smoother experience for the user. For mobile devices, I changed the layout to alternate between showing contacts and messages, and a back button to get out of the current chat. WebSockets are an important part of this project. Let's look at how two computers can interact using a database and a server. Computer A can store some information on the database, but computer B can't see that information until it asks the server for it. Suppose the information is a chat message. If we want to see that message promptly, say within 1 second of it being sent, we need to make a request to the database once every second to see if anything has changed. This is a computationally expensive way of doing things. Now let's consider a WebSocket server with event handlers. The server receives a message event from computer A, and the message data contains the recipient information, in this case, computer B. If computer B is also connected, the server can send an update straight to computer B. So, by using a WebSocket server, the client can wait for the server to send an update instead of repeatedly sending requests to the server to look for changes. Now, the problem with WebSockets is that if computer B isn't connected to the server when it passes on the message, they don't receive the message. The WebSocket server doesn't store the message to send later. This is where a database comes in. On this chat app, when a message is sent, it is transmitted over the WebSocket server as well as being stored in the Mongo database. When you open a conversation, the previous messages are loaded from the database, but with a single request. Any further messages received will now come from the WebSocket server, and this is computationally more efficient. I tested my Express server using Jest unit tests. Each endpoint was tested to ensure it provides the expected status and response body. I made a seed function which populates some test accounts using a file of random names. This seed function repopulates the database between tests because some of the tests edit the database. In the production environment, the live database URL and credentials are stored as a secret environment variable. If the server can't find this, for example, when it runs in the test environment, it uses the local testing database. I added this test suite to a CI/CD pipeline using GitHub Actions. This means that I will be alerted if any code is pushed to the GitHub repo that fails a test. This YAML script asks GitHub to create a local Mongo database and then run the jest tests. This script is triggered whenever anything is pushed to the API folder. I use Cypress to test the front end with some end-to-end tests. I first ran the tests using the Cypress interface to get detailed feedback and also to see in real time what was happening. Later, I also added the front-end tests to a CI/CD pipeline. One interesting aspect of Cypress testing is stubbing network requests. When the Cypress test framework runs locally on my laptop, there's no problem because the Mongo test database is running and hosted on my local host. However, GitHub Actions runs in a blank virtual machine, so there's no test API to get the data from. One way around this is to actually build the backend repo and Mongo database within the front-end test pipeline and only start Cypress testing when that database is running. That's what I did on this project, but mostly because I wanted to see if it was possible. If the database was of a much larger scale, then rebuilding the whole database would be a computationally costly way of doing things. Another way is to tell Cypress to intercept the network request to the API and create a mock response. I could have provided all of the seed data for the front-end tests this way. However, one drawback is that the mocked API responses must stay up to date with the real API. The real API could change the format in which it responds. Again, if this was a larger project, this would be a drawback, as the front-end testing team would have the additional responsibility of maintaining and updating a mock backend. I did use network stubbing in this project by intercepting certain API requests and responding with a 500 status code. This way, I could artificially create a server error and test that the front end responded appropriately. Hey, thanks for checking out my project. You can contact me on LinkedIn if you want to chat about any of the topics in this video. Take care, bye bye.